Welcome back to the series, and this time it's LangGraph 102, adding ToolNode and Conditional Edge. This guy right here, and in the previous video 101 we just covered the basics, and this is the overall plan for the series. That said, let's go to a diagram where we can explain things better, touch up on some LangGraph lingo. We couldn't do that last time because the graph was too simple with one node. This time it's about to change. Let's jump on. All right, so our last graph was simple. It had a start signal and an end signal and one single node. This node was the starting point and ending point both, so it was very simple. But this current graph we're about to build does have a start signal, but then we have our main node, which will connect to our tool node via a conditional edge, and then tool node will finish the circle by attaching itself to our main node via a normal edge. And as you can see, these are the basic lingo of LangGraph. The functions or modules or agents are going to be called nodes or tool nodes, and then the linear edges without logic connecting two nodes are going to be called normal edge, and the conditional edge are the traffic cops that will redirect the traffic based on logic. That said, let's go to a little bit more complex structure to understand these things better. All right, so this is the kind of structure you will find in the real world, where the human will talk to the prompt node or the first node, and this will be our starting point. And then that node might be connected with a whole bunch of other nodes via a conditional edge. And that's why they're going to be called a conditional edge, because they're going to be the traffic cop redirecting traffic according to logic. And the normal linear connection between two nodes are going to be called normal edges. And here also we have another type of relationship between a node and its tool node. Here also they're going to be one conditional edge and another normal edge completing the circle. And then in every direction there will be an end signal ending the progression of the graph. That said, let's get started with the code. All right, so let's not waste too much time on this. This is just installation, bringing in Langchain Community LangGraph, and a whole bunch of LangGraph model functions, and showing what is the Langchain and LangGraph version currently. Langchain is now at 0.3.14, and LangGraph would be 0.2.62. That said, now let's look at the loading of the API keys. Kept it very simple as usual, and this block right here will help us connect to our Langsmith portal. And as soon as we run our first model or invocation, this will show up as LangGraph Tutorial 100 series right about here, and that will maintain all the conversation details, error messages, etc. Extremely helpful for debugging. That said, now let's move on to our main event. All right, finally we are at our LangGraph 102, adding tool node and conditional edge, and these are the steps we're going to follow. Step 1, loading the imports. Step 2, initiate the graph. Step 3, creating the tools. Now this is a new one. Now, we did not have that before. Step 4, building the LLM with tools and adding the tool node to the graph. This is also another new step. Now, step number 5, creating and adding the main node. This we already have seen before. Step 6, creating the conditional edge and adding the edges to the graph. See, this is another brand new one. And then we have step 7, adding the conversational memory and compiling the graph. We saw that before. And finally, we chat with our graph. That's that. Let's get started. All right, so let's import our libraries and necessary classes. We have seen this before, annotated from typing Python library, and typedict also from Python extensions. But only new thing coming this time is the literal, and we will explain what all that about. And then of course the state graph, which maintains our entire state architecture of the graph. And then add messages. This is the guy here with typedict and annotated we actually give it the data structure. We elaborated on it last time, but then again, let's have a refresher. All right, so basically this is what's happening. This is what our state data structure is going to look like with the message variable, which is a list, and that's what we annotated with. And add message will be adding these tuples in this structure. That's what is happening right here. And for our friends who are coming from a different background, which is TypeScript background, like I am, so to describe it to them, I'm gonna show this one right here. In Python, whenever you see structure like this, you pretty much use this class typedict as a parent class to build a new class, which is a new type interface called state, and then describe your message variable using a list of strings, right? And in here, if it was TypeScript, this is exactly how you would do it. Interface state extends typedict. Here, typedict is extended like this, and in TypeScript, we do it like this, and the message variable will be a string array. Just to help out a fellow friend, and just to recap, this is going to be our state variables data structure. Now let's move on. All right, so extra stuff that we're bringing in here is the tool node from LangGraph to create our tool node, and the tool decorator from Langchain tools to create our tools, and of course chat OpenAI to create our LLM. Now let's move forward. All right, so now that these guys are done, we're just going to run them, and let's create our class. Boom. Now let's move on to creating the tools. All right. Okay, so I have created two absolutely basic functions as tools, which are very testable, very simple. And the reason I did that, so that we don't get too wrapped up with the complicacy of the tools itself, and we can, maintain our focus to LangGraph learning, right? So as you can see, add tool here, these are the decorators that Langchain gave us, and these decorators turn these functions into tools, right? And let's look at the first one. Very simple, get weather. We're going to receive a string as location, and this is the system prompt we're going to give it. And here's something about the prompt engineering I should mention. Let's see what we're saying here. Basically, this function called to get the current weather. Initially, I just kept this line in there, right? And then I kept having all sorts of issues. Some of them were skipping it, some of them were adding their own stuff to it. So that's why, to make it specific, I had to go use the response of this tool verbatim, use this anytime asked about the current weather. I had to be very assertive, very clear as to what I wanted it to do. Only then I got the correct result. So be very careful, and this is where the prompt engineering comes in extremely handy. So as far as the function goes, it's very simple. If we receive New York, it just returns it's cold and wet as the current weather. Anything else will simply say it's warm and sunny. And anytime we get this stuff, not something that AI made up, we know the tool was used properly, right? The next one is another simple one, get AI status. We're gonna send a string as a company name, and then exactly same way we're saying call this to get the current AI status, use this response verbatim, and use this anytime asked about current status of AI of a company. If we ask the question as Google, is gonna say Gemini is pretty awful, and anything else it will say overall AI status is good. And when we get these answers, we know tool was used properly, right? And right here in a tools variable, we create a list of our tools, get weather and get AI status. Just to show you how simple this is, we're just gonna simulate the result, just to see what AI will see. Let's run this. Boom, there you go. Gemini is pretty awful, right? So let's disable these. We don't need them anymore. Run it again. All right, perfect. So now let's move on to step number 4. All right, so step number 4 is building the LLM with tools and adding the tool node to the graph. So first, we just create our LLM with chat OpenAI model GPT-4o, and then we bind our tools with our LLM with this variable LLM with tools, LLM.bind tools, and then we pass these tools right here, this array or list of tools right here to create this connection, this brand new LLM. And once that is done, we create our actual tool node by using ToolNode. This is the method that we're bringing in from LangGraph. And once again, these tools are being passed to create the tool node. Now, at the beginning, I used to get confused. It's like, there are two places we're sending the tools. Seemed like a repetition, right? But the explanation to this is the actual workbench where AI will come and invoke the tool. And this is pretty much a roadmap. We're just telling our LLM where to find the tools. This is only a directional purpose. But actual workbench is this tool node. So now that we have our LLM and tool node both ready, we're going to go ahead and use graph.addNode and add the tool node to our graph. And this is just the name of the node as a string. And this is the function that we just created. That's that. Now let's move to number 5. And we are very familiar with this. Here we just create our one main node, the prompt node, and passing the state as an argument and returning messages. But instead of LLM, we're using LLM with tools dot invoke and state messages. And with that, now that we have our prompt node defined, now we use it straight up here, and this string would be our node's name, prompt node. And once again, we use graph.addNode to add our main node to the graph. Now let's go to our conditional edge. All right, so a lot happening right here. We are initially defining our conditional edge, which is this function here, conditional edge, taking in the state and returning a literal, which is a tool node and an end signal, right? Now, what does that mean? Let's elaborate. All right, the question is, what is literal? Literal is part of Python's typing module. It allows you to define specific constant value that a variable or return value can have. Now, the operative word here is constant, right? As you can see in this sample function, get direction, we're returning a literal of north, south, east, and west. Only these 4 strings are allowed to be returned, at least one of them, right? But anything else will not work. For example, let's say your function is pretty complex and it ends up returning up or down, right? But once it tries that, this literal will catch it. It will only look for east, west, north, or south. Anything else is going to raise an error. And the implication of that in our case, in our conditional edge, is that we're also turning our output into a literal or a constant. Whatever this function returns, only valid output we will accept is either this tool node or an end node. That way, restricting our output to a constant like this, right? And when that happens right here, as you can see, we just check up on our last message, state message -1. And by now we know that this is always the last message, -1. And if this message ends up being a tool call, then we will return tool node, this guy, otherwise the end signal, this one. So basically what's happening is, once we connect this conditional edge, like here, graph add conditional edges, this will be our edge between prompt node and our conditional edge. When AI comes to that and it returns a last message asking for a tool, or if it's a tool call, then our edge will return tool node. That will tell our LLM to go find the tools. As you saw before, we bound our tools. That means our LLM now knows the location of those tools, and it's going to go ahead and use it. And once done, comes back, then this last message will no longer be a tool call. It will be the result. That's when this function or edge will return the end signal, thus terminating that flow and redirecting the flow of the graph elsewhere. And with this graph.add conditional edges, we're connecting prompt node to the conditional edge, just like in our diagram. Let's go back quickly. All right, so this is exactly what's happening. We just defined our conditional edge, and then by adding to the graph and mentioning our prompt node and tool node, we just created this connection right here. And when we go back to our code, you will see that the normal edge is coming up that will complete this circle. Let's go back. All right, so as I just said, now look, the next step is connecting the normal edge, graph.addEdge, tool node, and prompt node. This connection is a normal edge that completes the full circle, right? With that done, now we are only left with setting up an entry point or starting point for our graph with graph.setEntryPoint prompt node, so that the graph knows this will always be our starting point. And that being done, our graph is now ready to be compiled. We could do that, but we're not going to, because now we're going to go ahead and add conversational memory to it and then recompile, right? So to do that, first let's bring in LangGraph checkpoint SQLite. All right, now that it is here, let's go ahead and create our memory and finally compile our graph with memory. So we're just going to run this. All right, now we can see why it failed, because we did say this happening, but we never really ran it, right? So let's run it. Finally, now we have our entry point. So look what it's complaining about. Graph must have an entry point, right? So it didn't see that because we forgot to run this. All right, so now let's go ahead and finally create or compile our graph with memory. Oops, the tool node. Okay, so as I was so excited about explaining everything, I keep forgetting to run these. So I'm just going to go ahead and run the whole thing all the way from the top. All right, so create the tools, and then let's create the LLM. Now let's go ahead and create the main node, add the main node, conditional edge. Okay, so now we should be ready to create or compile our graph. And we do. Boom, there you go. This is the structure of our graph. And at this point, we are ready to go ahead and have a conversation with our brand new graph with tools. And we are all familiar with this from the last video. We're just creating an infinite loop with a while true and getting a user input, and then have a breakout logic. If we type in quit, exit, etc., we break out of that chatbot loop. And now we have our config variable, configurable thread ID 1 or session ID 1. And this is how this guy, the SQLite saver and memory saver, maintains the session memory. And once that's done, we just use graph.invoke message user input, which is gathered right here, and send in the config and get our reply as a response last message. So, and here we're not going to talk too much. We're going to simply test our tool usage and the memory very quickly. Let's go run this. All right. Hi, I'm Moose from Atlanta. How can I assist you? Great. Now let's ask, what is the AI status of Google? Boom, there you go. Gemini is pretty awful. All right, so we know our tool has been used. Now let's ask the same thing. AI status of OpenAI. There you go. Overall AI status is good. Perfect. All right, now let's check the weather. Current weather of New York. There you go. It's cold and wet. And let's try another one. Current weather of Paris. Warm and sunny, just like our tool says, right? Now, last but not least, I'm just going to ask him about my city, not mentioning the city name, to check the memory. Tell me about my city. Here we go. There you go. Wrote a book on Atlanta. And that, my friend, is the proof that it not only used the tools properly, but also has the memory to continue a decent conversation, right? Gonna get out here. And not only that, I'm working on making another video and test the same thing with other models, and then you be the judge. Now that we have this, we're just going to check our friend Langsmith here. All the conversations, everything got recorded, and we could go into any one of them, find the details, conditional edge, get AI status, OpenAI, use conditional edge again, etc., etc. With that, I conclude LangGraph 102, where we extended our graph with ToolNode, added conditional edge, and tested tool usage and memory with the chatbot. Coming up next, we're going to test our graph with Claude Sonnet, Llama, Gemini, and more. All those other models, and see how they react to our tool use and how they handle memory at the same time. Please like and subscribe, and thanks for watching.